Now it should pop alert. Don't embarrass me again. Yay, finally. Hi everyone, welcome back to our channel. This is Asim here. So today we are going to talk about XSS and we are going to see how we bypass CSP in a recent BugPoC challenge. So don't get intimidated by CSP and XSS and all that. If you don't know, this is gonna be a detailed video. So I'll be explaining first what is XSS, the types of XSS and all that. And then we are gonna see what is the CSP, how it is implemented. And eventually in the demo part, like in the second half, so there I would be showing how I solved the BugPoC challenge, what was the thought process throughout it, and like what are different things and payloads and method that I tried. So we'll be going throughout like whatever mindset I put into that. So watch it till the end and you might get something to know. Just a disclaimer, I'm not an XSS guy. I don't do XSS a lot. Even like this was like the most that I've ever done with XSS. I usually I don't look for XSS a lot. Mostly I look for business logic bugs because I like looking for those. So yeah, I learned a lot during this challenge. Thanks for BugPoC. A few channel updates. So you could see that I got a new mic here. Probably you would have seen in the community update section. I posted it there. And yeah, I also put a new light here so that I could record even during the night. Like earlier I used to only record in the morning during the daylight. So that's that. Let's start with this. So there's a write-up of this solution, the BugPoC solution. I've tweeted on my Twitter, you could check that. So yeah, so first thing, what's the XSS? So XSS is cross-site scripting. Probably you would have heard it. If not, I would talk about that. So this is the overview of the whole video for this. So there would be what is an XSS, types, is it still relevant or not? Then some of the modern protections against CSS. Specifically, we are going to talk about CSP. Then I'm going to show the demo of BugPoC challenge. And here on the right of the screen, you could see it's like one of the famous XSS. It was found in TweetDeck, and it was like one of the most retweeted tweets at that time. So first question is, what is XSS? So if you could see the graphic on the left side, so there you could see that there's a attacker. He injects some script into a trusted website, and a victim who visits that website, because the script is already into that website, that malicious script gets injected onto the victim and it gets executed in the victim's browser. So basically it's executed in the victim's context. So that is cross-site scripting. So like using a website where the attacker's code reached the victim's code like browser and then it got executed. So it's basically code injection. It was first coined by Microsoft developers in the year 2000. What are the potential impacts if you ask me? So it could read all the cookies except the HTTP only cookies. So there's a flag on cookie that's called HTTP only, which instructs the browser that only when sending a HTTP request that cookie should be accessed and not by using JavaScript. So otherwise JavaScript could access all the cookies. So if there's a session cookie and there's no HTTP only flag on that, so that cookie could be easily accessed by JavaScript. And since we are talking XSS, so an attacker could access those cookies and basically impersonate as the victim. Then any other thing that the victim sees or uses or changes or any action that they can do, the attacker could do the same using the XSS that they have victimized someone. So if there's a webcam access to a browser web page, suppose you are doing Zoom call or maybe you're doing a Google Hangout call, and that particular website has XSS into it, so the attacker could gain access to a microphone as well as webcam. Also, no CSR protections would work, because CSR protections usually they have this nonce, the random value, into the HTML of the web page. So JavaScript could easily interact with the HTML of the web page, so they could get the CSRF token and do whatever, bypass all the CSRF mechanisms from there. Let's talk about the type of XSS. So prominently there are two types. persistent and non-persistent. DOM based XSS is a like kind of subset of that. So persistent XSS is more kind of dangerous because the XSS remains there, and non-persistent is reflective. So for like examples of persistent XSS could be, suppose there's a forum or maybe on Facebook there's an XSS. So if I create a post and that post remains there, so that's like a stored XSS because that code is still there. Reflected XSS could be like, suppose if you are searching like you are doing a search on Google, so that string gets reflected on the page itself, right? So if there's a potential XSS there, if there's a XSS there, so that string, that is a reflected XSS, because whomsoever you give that search link, they would also like get a reflected XSS, or the string would be reflected, and since that's a XSS payload, so that would get executed on that. Fortunately, Google doesn't have a reflected XSS on that, so that's a good thing. It used to had one time, like a person reported that, and like it was a good thing. There's a video by Live Overflow on that also. Like these kinds of XSS are also categorized in two parts, like server and client. It's similar thing, there's difference in terminologies. Some of the famous XSS. So Sammy is my hero. So this was in October 2005, and it's also known as the MySpace form. So what happened was, Sammy Kamkar, who's a very known researcher in the security community, he created an XSS and he added it to his profile page. So that was a stored XSS, and once anyone who visited his profile page, they like, there's a hero section on MySpace. So in that hero section, Sammy was automatically added to the hero collection, and also if they were not a friend of him, so or her, they would be sending a friend request to him. So that's how he got like over 1 million friend requests, and everyone who visited, so this code also got copied onto their profile. So anyone who visited their profile, they automatically send requests to Sammy as well. So it was very like it spread very fastly. Like in 20 hours, there were around 1 million requests, and MySpace had to shut down operations for I think 1 or 1.5 hours to just restore normalcy to the social media. Second XSS, the famous one, is in TweetDeck, which I already showed. So it's in the left side of the screen. So it was in June 2014. There, this person created this XSS using TweetDeck, and whomsoever visited this tweet on using their TweetDeck, it automatically got retweeted. So it was around like 64k retweets were done, and it was the most retweeted thing at that time. So you might think that this XSS is kind of a thing of the past, but not exactly. It's still very relevant, and if you go by HackerOne's 2020 report, like it was the most awarded vulnerability with a whopping $4.2 million payout. It was up 26% from the last year. Also, in the past 6 months, there have been two big XSS bounty that was paid by Facebook. Like one was 20k and the other was 25k. So both of these have very good write-ups. I have added the links in the description so you could read from there. Some of the modern protections. So because it has been a like very old thing, like since 2000 it has been like in that place. So some of the modern protections include like filter input on arrival and encode data on output. So the very basic rule of cybersecurity, or like input and handling data, is that never trust user data. Repeat it with me. Never trust user data. So whatever data you get, filter input on arrival and encode data on output. So that would help you protect from excesses. Third point is use appropriate response headers. So like if you are returning a HTML file, explicitly mention it that it's an HTML file. If you are returning a JPEG file, explicitly mention that it's a JPEG file, so that there is no XSS vector that's like being executed in maybe a picture file. Last point, and probably the most like secure thing or most protective thing, is content security policy, and we're going to talk in detail about this. So if you see the right side of the screen of this presentation, you could see that in the headers in this part there is content security policy, and there are some strings written like script source, style source, and image source, and all these are like attributed with self. So we're going to talk what this self parameter is and what these tags are. So CSP is the content security policy. It's an added layer of security that primarily helps in mitigating XSS requests, XSS attacks. So it also helps in reporting XSS. So there's a report URI parameter. So there you could, if any XSS attack is prevented, it's being reported to that URL. And on the right side, the screenshot is for Gmail. So it's the content security policy of Gmail. And you could see there are a lot of URLs from where script is being loaded or frame is being loaded. So there are a lot of whitelists there. Let's see the common examples or patterns of CSP. So if the content security policy dictates that default source is self, so it means that anything that's being loaded, whether it's an image or whether it's a script or maybe frame, so the default source, if other sources are not explicitly mentioned, it's self. So that means that only the same website and content from the same website could be loaded, not any of their domains. Like if the website is trusted.com, so only trusted.com and like folders from there could be loaded, and not from any domain of subdomain of trusted.com. Second example is a bit lenient, where they are allowing to load data from any of the subdomains of trusted.com, which you could see that it's represented as star.trusted.com. So it's quite easy to understand. This is a verbose example I explicitly added because I thought it would give a more better insight into what the different tags like they stand for. So default source is self. Again, it means that if sources for other things are not defined, so by default it should be assumed that it is a self source. Self meaning from the same website. Like here you could see that script source is defined, whereas maybe frame source is not defined. So by default frame source would be also self. Then comes image source, which is star. So image source star means that images can be loaded from any website throughout the internet. Then comes media source. So you might think that images are media as well. So we are not talking about that media. Rather, media constitutes for any audio or video element. And these could be only loaded from media1.com as well as media2.com. So these might be the servers from where content is being loaded for the particular website whose CSP we are talking here. Then comes content script source, which is a particular website, userscripts.example.com. So any script that's being loaded onto the page should be from userscripts.example.com, and only from that place, no other place. So that's about some of the common examples. One thing to note is CSP with nonce. So I'm going to talk about this in the video itself and why it's relevant for us in solving the example. So it might be that without this also you could solve, but while I was solving the challenge I talked about it. I have not written it in the write-up because I thought it would be unnecessary, like increasing the thing, but while I was solving it I also read about this, so I thought it's worth mentioning and talking about. So a nonce is a randomly generated token that should be used only one time. So probably you would have seen that in CSRF protection there is a random value for the CSRF token. So that's also a nonce. So what happens is in script source there's this nonce values, this nonce value is inserted instead of, like in the early example you saw that script source was userscripts.example.com. Whereas if you see the nonce example here, its usage is script source and then nonce hyphen and then that random string. And what the page should have, that every script tag and every script that's being loaded onto the page, they should have a nonce property, and that value should be equal to the value that's being inserted into the content source, like contents like in the CSP. So since the server is sending the CSP header as well as the HTML page, so the server already knows the random value and they could easily insert it. However, if a person they are trying to execute a code, they won't be knowing the nonce value, and thus any XSS attempt would be thwarted. So that's a very strong protection with nonce. Now let's talk about BugPoC challenge and gets our hand dirty. So there was this Hack the Amazon job interview challenge. It was announced on 28th October. Coincidentally, I also talked about a CSP. I tweeted about a CSP thing that day. I didn't know about it, but I was just casually reading what it's there. So this challenge was that you have to solve this XSS CTF. There was some prize money for the first few winners, and then if you could solve it, you would be able to skip the first round of interview for some of the Amazon jobs. So that was that. I saw this tweet later on, and the challenge started on 4th November. I started this on 6th November, and I did something, but during the weekend I didn't do a lot on this. Then again on Monday I started doing this, and I found, so this is the kind of a timeline, a vague timeline, and it's also a TLDR kind of thing. So let's start with the demo now. So this is the challenge website, and you could go and try this. I would add the link in the description. So while it's still up, you could try this. So if I write like hello hacking simplified, so it would get displayed here, and make wacky would turn this into a wacky statement. So the first thing that I always suggest, that you should look at the source. Also, you should look at the developer console, because some of the things might not be displayed here, whereas you could see that here. So the main reason I check this is because I want to see if there are any comments or there's any sensitive thing that's left out here. Also, I checked for like custom made JavaScript and CSS files. So you could see that this is style.css. Then there's this iframe which has the ID of the iframe, and then there's this files bugpoc.png, and there's script.js. So JS files are usually interesting. CSS file you could ignore this. So it's only able to run on Chrome. I had already checked that, like in Firefox you cannot run this, and also on the latest version of Chrome. So that was the condition of solving it. Then there's this document.getElementById, and then there's this. So here they are replacing any of these tags or value with a like empty character. So if I copy this here and I paste it, you could see that it's automatically being replaced or deleted. So I cannot write here script tag or image src or things like that. So for that, to find my way around, I prefer using burp and like adding the payload there. So I've already switched on my burp. So if I do like ABC and I do make wacky, so this gets encoded here, and I could just write script image src whatever I want to write. So for right now I am just gonna leave this here. Forward. So that's that. Let's see the console. So in console you could see that this frame analytics script securely loaded. It's being loaded from a frameanalytics.js file. It's somewhere there. Now let's see the like how the data is being printed here. So if you could see, if I right click and check the element, so this is the iframe that's loading whatever data we have inserted into that, and when pressed make wacky. So if I do this like QWERTY and I press make wacky, so this iframe would display make wacky, and you could see that this param value has been updated. So maybe we could open this iframe into a new window. We would see that as well. So if I go and check this, so here very instantly you could see that there's this QWERTY value is being reflected here in title tag, and I'm not sure whether anywhere else it's being represented or reflected there. And also there is this something weird thing going on here. Then there's this style tag, we can ignore this. Then there's this body, and in body there's another iframe which has sandbox and things like that. So I prefer opening it in a new tab. So let's open it in a new tab. So here this page can only be viewed from an iframe. Let's see what is the protection that's like disallowing us from doing that. So if we go down at the bottom, you could see that if window.name equal to iframe, then load this, else load this error page. So it's checking as iframe using a window.name function. So we would see how we have to bypass that as well, and why we need to bypass that first of all. Then there's this thing. So this might raise your like alertness why this is there. So it's basically alert function is also being overwritten kind of thing. So once you alert inside the iframe, this string also gets executed. So let me show you. So if I do this, so undefined, and this is the string, so that particular string here, it's base 64 encoding of this value. So let me show you this. So if I do this a to b, so this is that. So you have to basically execute alert into the iframe and not in the top window or any other place. So let's come back to this. So yeah, let's close this. We don't need this now. So we see that in the title tag there's injection, and probably we could, if we close the title tag and insert a script tag, we may be able to execute an alert into the iframe. And since we are able to insert alert into the iframe, we would like easily pop up that nice job thing. So let's do that. Let me intercept the traffic here. QWERTY123 make wacky. So these are some of the payloads that I have tried, and this is the final thing. So here we are closing this title tag and inserting the script alert. So let's encode this first. Encode as URL proxy. Proxy. We could clear this. Let's forward this here. Yeah. Now we just need to see here. So in console we got this error, refuse to execute inline script because it violates the following content security policy. There's this content security policy that's disallowing us from executing the script. So let's first check whether the script was like injected or not first. So if we go to the iframe document HTML head, so you could see that title tag has been closed and there's this script alert document.domain. So we are able to, like, we are in the right direction, we have inserted in the right place, so that's fine. Now we need to bypass this thing. So let's check first what is the CSP that's being passed from the headers. If you go to HTTP, so this was the code, yeah, edited request, and then there's this response. So in the response, if you check, this is the content security policy. So usually I check on, there's a website called CSP evaluator. So there, if you paste the content security policy string, it would evaluate you and let you know whether it's vulnerable or not, or what are the like shortcomings of it. So here you could see that base URI is missing. Missing base URI allows the injection of base tags. They can be used to set the base URL for all relative URLs to an attacker control domain. Can you set it to none or self? So, and if you see the severity in the legend bottom, so it's a high severity finding. So in short, what it means that if an attacker can insert a base tag, so they can control any of the resources that's being loaded from a relative path. So if I could inject a base tag with maybe attacker.com, so if there's a resource or JavaScript file that's being loaded from a relative path, so that would be loaded from attacker.com / whatever path is. So let's check whether there is a relative path here or not. So I check the source for this. Since we are injecting into the frame thing, so we should be looking there if like whether we could inject, because we are injecting base tag here, so we should be looking for any relative imports in this particular path. So this is the first script, and you could see that this has the whole URL from where the JavaScript file is being loaded. Then there's the script tag. This font is also being loaded in the full URL. Let's come down. There's this random function which is creating that. The last function is this. There's this window.file integrity object. So it's this file integrity object is being accessed from the window object. Then this iframe thing and file integrity.value. This value is being checked here, whether it's like there is value or not. This is for securely loading the frame analytics code. Then if you see, they are creating a iframe, and in that iframe they are adding its sandbox element, allow scripts, allow same origin. So I think I already showed it here, but let me show you again. So let's close this. So this is the iframe that we are talking about, allow scripts, allow same origin, class invisible. So that's here, allow scripts, allow same origin, class invisible. Now let's so yeah, So I've zoomed it a bit. So if you see here, so they are also creating securely add the analytics code into iframe. So they are creating a script element, and into that script element they are loading this frame analytics.js from a relative path. So that's very nice and very kind of them. So we could insert a base tag and we could load this frame analytics from our own server. So for locally creating a server, what I'm gonna do is I have this BugPoC thing here. Let me change the opaque thing. Okay, let me show you. So here is this files analytics.js frame analytics.js. So if I show you the tree thing for this, oh, I don't have apt install tree -y. So I'm installing a tree command that would help like show the directory structure of this. That's quite nice to see. So yeah, so this is where you could see that there's this files directory analytics.js and then this frame analytics.js, and there's this main py. So main py helps run a local server with CORS headers, because we are going to access it from some different server, so we need to have the access control CORS headers on it. So what we are going to do is we are going to run python main.py here with a port like 8000, and then we are going to run an ngrok server which will give us a public IP. So we need a public IP because this website, when this would try to access it, it should be able to access from like a public server. So let me run this python 3 main.py. So it's running on this. Now let's run ngrok http port 8000. So since this is running on port 8000, so this would map to port 8000. So if I just go and visit this website, you could see all the files being listed here. That's there in this directory. So BugPoC files and like the JavaScript file and all that. So you understood, right? So what we're gonna do is we're gonna just let me show, since we're already there, let me show the content of that. So it just have this alert thing, alert document.domain. So we could remove this file as well. So here it is, the frame analytics.js. So this is like later on I did this window.top. Let's remove this. Now we have this file, and what we have to do is we have to insert the base tag. So this is the payload that we are going to use. Just replace this ngrok URL because we have got a different one now. So this would mean that all the relative URLs will be loaded from here. So yeah, let's close this. This is not needed. This is not needed. Okay. Now whether I'm intercepting the traffic, intercept is on, make wacky decoder, forward the traffic. So this thing we have to repeat again and again. Like whenever we create a new payload, we would be creating the base URL encoded thing of that and then inserting it here. So let's see what happened. So failed to find the digest in the integrity attribute. So this file has been loaded from our site. So you could see that ngrok, the URL from where it's being loaded. What happened was we failed the integrity check, and this value is the SHA-256 value of our code. So that alert document.domain. So the SHA value for that is this, and the resource was blocked because this integrity didn't match. So if you see this here, there's this integrity value. This is the integrity value. So if our script had matched this value, then it would have been executed. So here I got stuck and I was not sure how I could bypass this check. So there was a hint from the BugPoC team, and that had something to do with clobbering. So I searched about XSS clobbering, and I found this article about DOM clobbering. So what it does essentially is that you could, if you create element with the same name, so like there's this window.sum object, and if you create anchor tag with the same ID, so when the browser tries to access like window.sum object, they would be accessing this value, this element, because it's coming in the earlier than the window.sum object script tag. So If this is below that, so if the browser access window.some object, they would be accessing this value. So you could easily guess that if there's a value thing like window.some object.value, and if there's a value parameter here, so what the browser would be doing is they would be accessing the value in the anchor tag and not the actual JavaScript function. So if you see the similarity here, it's this, and we are bypassing this. So instead of that, we have this window.file integrity thing, and we need to bypass this value thing. So I used the DOM clobbering thing to do just the same thing. Instead of anchor tag, what I did was I created this input tag, and I gave it ID as file integrity and the value of whatever value I got. So this was the value that we got from here. So this is the value. Let me copy visible style selection. Let me paste it here. So this is the value for that, and now we are good to go. So what this would do essentially is that it would, like, the base tag would be inserted as is, then the body tag would start, and the first element would be this input, and its ID would be file integrity. So when the iframe is trying to find this window.file integrity, this would find this, and when they would be accessing the value of it, which is here, file integrity.value, so they would be accessing this value. And so essentially we have bypassed this SRI, or sub-resource integrity check. So it's sub-resource integrity check is basically done to verify whether the sources that has been loaded are valid or not. Like if CDN, like from where we are loading this resource, if they have manipulated the file, so we could check the integrity because we already had the SHA of that particular file. So let's inject this payload. Yeah, I think we're good to go. Let me enable this. Make wacky. We have inserted this after encoding it. Now let's see what happens here. So it says ignored call to alert, the document is sandboxed and allowed modal is not set. So this is because like I showed earlier as well. So our script is being loaded into this iframe. So there's this create element iframe which has this sandbox thing, and it has allow scripts and allow same origin. So if I show you here, this is the iframe, and then there's another iframe here. Where is that? Yeah. So in this iframe, our script is being loaded. Here you could see that script source this is, and the SHA value. So we have bypassed the integrity check, but we are still not able to like alert the model because it is in a sandbox frame. So, and the sandbox only allows scripts and allows same origin. So what it essentially means, so there's this Google Chrome's GitHub IO. So available after Chrome 46. So this is like Chrome 83 or 86 version. So that's why they intended that you should be running the latest version. So that was one of the prerequisites of the challenge. So what happens is sandbox frame will block modal dialogues by default. So modal dialog is any like alert pop-up and confirm thing or prompt. So these are all modal dialogues. However, if you really want to allow modal dialogues inside a sandbox frame, you can still add allow modals. So I was thinking like how I could allow modals and to bypass this, but I got a way around that. So what I was doing is I was accessing the window.top element of it, and since this iframe allowed scripts, so window.top would mean this particular web page, and from there I could run this, like execute this code. So the payload for that was, I think this was the payload. So let me show you what actually happening. So I would be changing this value, and you could calculate this using OpenSSL as well, but I prefer like I would just see the error here and copy the integrity value from there. So let me just do this make wacky thing, and where's that decoder? Yeah. So this would fail because we have changed the frame analytics code and we have not updated the integrity value, but we're waiting that Google Chrome would already display the actual integrity value, and we are just gonna copy this here from here. So after we have copied it, what you have to do is you just need to update this thing. Let's do this again. Decoder. Make wacky. Let's clear this. So what we have done is we have updated this frame analytics code, and you could see that this alert has popped up, but it's not the actual solution, because first let me explain what this happened. So from this iframe, like this lower iframe, it tried to access the window.top element, and so window.top element is this page, and from there it tried to access this element ID by the name the iframe. So if you see the iframe, so this was the iframe. Where is that? Let me show the source of this so you could see. Yeah, so this is ID. So basically I'm trying to access this element, and from when I got hold of that element, I am running this alert pop-up from there, ifr.contentWindow.alert document.domain. So that's how you alerted it from there, because we wanted to run alert from this particular iframe. So that's why I was first trying to get the element and then run the alert from there. So the reason this is not a valid thing is because like there's no like single click XSS, like you give the victim a single URL, they click it and the like payload gets executed. It's not like that. So that's why it was not qualified. So after I got this pop-up, I posted on Twitter, and I then raised a HackerOne report as like a short write-up for that. But then like BugPoC Ryan, who was triaging that report, he told me that it's not like the victim, there's no single URL for this. So you need to create a attack link, so that once a victim clicks on that, they automatically get this pop-up there. So I figured out that, okay, this thing is what we are inserting here. So this value, if you see in the decoder thing, so what I'm essentially doing is I'm inserting this param value as this. So if I could like give this link directly to a victim, and if they are able to execute it, so basically our work is done, right? So so this is the URL that needs to be sent to the victim, and if that they click on this, the frame should get executed. But the problem with that is that it's checking the window.name, and there we get stuck because we don't have this iframe name, and that's why we are not able to directly going through the link, we are not able to click on that. So I then checked for this how I could bypass this. So I searched for XSS window.name, and the first thing I got was like, it was totally relevant for the work I was doing, and it mentioned that the other way to get hold of another window is to pop it out. You can specify the window name in the second parameter. So this way, window.open, then you insert that XSS link, and then you gave a name for that. So here I would be giving a iframe name. So the name of the window should be iframe, and that would match all the conditions here, and it should automatically run the code. So that was very simple, and I also read the MDN docs and confirmed that okay, that's all that I need to do. So I created this a.html file. So what I'm doing here is I'm opening that particular script in frame.html into a window that's name is iframe. So that basically bypasses all the checks. So if I go here, so this is the URL. Let me copy it here and just paste it here. So it looks good. I hope you understood what I'm doing here. Now let's open this. So for opening, I just need to open this URL. So where's that? I just need to open the a.html here, and it should work fine for me. Let's see that. a.html pop-up is blocked. Let's allow this. So a.html, it would open a new window, and that window's name would be iframe, and there the code should get executed. So you see that frame.html is being loaded. So we bypass that check, but it's still not being executed because cannot read property content window of null. So if we see the frame analytics code now, so we are trying to access content window.alert. So it's showing it null because in window.top there's no element by the name the iframe. because right now the window.top is frame.html itself. So we just need to remove all this, and alert document.domain is fine enough. So let's do this. We would get a SRI error. We would change the value there then. So we get the value calculated from Chrome, and yeah, let's paste it here. Where's this file integrity check? So we got this URL encoded string. Now replace it in a.html, and we should be good to go. Now reloading this page, and this should pop an alert here. There was an error. Let me check what's the error. Oh, sorry, this should be window.top because we want an alert from there, not here. I'm always confusing it. So this is the actual value of SRI that should be there. Let's do this again. Now it should pop alert. Don't embarrass me again. Yay, finally. So that was that. Now let's show. So that was the demo. Now hope you enjoyed that. So these are some of the practice resources. I didn't know about DOM clobbering. I haven't ever exploited any CSP bypass earlier. I didn't know a lot about XSS. I read throughout it, and the challenge was like I learned a lot of things. So I would definitely urge people to participate in CTS and learn from there. You would learn a lot of things. Just doing recon and finding some low hanging bugs, like they won't add a lot to your skill set, right? So thank you. Hope you enjoyed the session today. And let me know in the comment section whether you like this detailed kind of videos. So I am planning to make detailed videos, like a single video, but it should encompass like a lot of things and reports and all those things. So thanks a lot, guys. Hope you enjoyed this session.